Similar triangles and primary trig ratios. First, we're going to focus on similar triangles. Okay? Right here, we have two triangles. Oh, I've written them backwards though. Actually, no problem. Let's just fix that.
What number is this?
This is just made up. This one. 4, 2, 4, 7. Okay? So, in order to be it's made up. In order to be a similar triangle, the angles in the two triangles have to be identical, which they are. Okay? All of our angles are identical. So, it doesn't matter that the side lengths are different. Our angles are all the same. Now, these are made up triangles. They're probably impossible triangles. I just put the numbers together so you guys can see how to go about doing this. So let's say I have this triangle, and they want me to solve for this unknown side and this unknown side. Well, what I'm going to need to do is figure out what number to multiply or divide by to get to 4. So what would I multiply 2 by to get to 4? That's right. So, since we know that's the case, in order to find out this side, I need to multiply 4 by 2. And that will give us what? 8. So this side will have a measurement of 8. And we do the same thing here. What will this side be? That's 4, and we just multiply it by 2. Okay? Now let's say that I was actually given these sides first. How do I go from 4 down to 2? We divide. So we use the exact same scale of 2. It's just a difference of dividing when going from a larger triangle to a smaller one, and multiplying when going from a from a smaller triangle to a larger one. So, next we're going to work with primary trig ratios. In order to use primary trig ratios, which you guys know as SOHCAHTOA, okay, you must have what type of triangle?
90 degrees.
Yes. For similar triangles, does it have to be 90 degrees? No. But for SOHCAHTOA, it does. Okay. Now, we know the rules here are sine theta, that's the angle, is equal to the opposite over the hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tangent theta, opposite over adjacent. Okay? Now, these ratios, all I want you to do is to be able to set up these ratios. So, let's say I asked you for sine 40. What is that ratio equal to? What would be opposite of 40 degrees? 6. And what would be the hypotenuse? That's it. I just want you to be able to do that. So if we had cos 40, what would that ratio be? Our adjacent is 7. Hypotenuse is 13, so 7 over 13. And then for tangent, 40 degrees. Okay, remember, this is all in reference to 40 here. Opposite is 6. Adjacent is 7. So we have 6 over 7. Now, with that being said, let's try another one. What if I said sine 50? This is a different angle. What would be opposite of 50? 7, would the hypotenuse change? Still 13. Cos 50. What's our adjacent now? 6. Hypotenuse is still 13. And tangent 50 is 7 over 6. Now, I want you guys to draw a reference to similarities here. Sine 50 is the same as cos 40, the ratio. Cos 50, I can do that in another color. Cos 50 is the same as sine 40 for the ratio. And if you know this, the two tangents are just inverses of each other. One is 7 over 6 and one is 6 over 7. Okay, so that's primary trig ratios and similar.